Well, hello everybody. I'm hoping this works. This is take number 5 on this dang video. It's just not wanting to get done. I got a tough day for you today. You missed a tough day the other day. This video, guys, I hope you hang in there with me. We're going to talk about vertical asymptotes, horizontal asymptotes. You're going to see what we call oblique asymptotes. The things that you need in front of you then, you definitely need that day 4 note sheet. There's a note card that goes along with this lesson. If you don't have it today, don't panic, because I'll say enough things in here to help you get it. And you're definitely going to need your brain today, because this lesson's probably going to be 30-35 minutes long. It's a tough day, guys, so hang with me. It's a very important day. This leads into calculus that we do next year. Or those of you that leave us that semester, you'll need it for college algebra. But some things that you're going to see today, you're going to see graphs that look like this today. You're going to see what we call the oblique asymptote today. That's this slanted line right there. You're going to continue to see a vertical asymptote like you guys have seen. You're going to see some graphs that have a vertical asymptote again, a horizontal, but this graph's special because if you look right there, there's going to be a hole in your graph. I got to show you how to get that point of discontinuity. But before we jump into the lesson, I need to review factoring with you real fast. So I'm going to fly through this assuming that you remember it, but just need a touch-up from your Advanced Algebra 2 days. If you look at 4x squared minus 9, notice that's what we call a difference of squares. So I'm going to go to parentheses. And I'm going to use the square root trick. The square root of 4x squared is 2x. The square root of 9 is 3. There is no middle term, so I need a positive sign and a negative sign in any order. Now set each of these equal to 0. So I'm going to get 3/2 for one of my answers, negative 3/2 for my other answer. Added 3 divided by 2, subtracted 3 divided by 2. If you look at x squared minus 2x minus 35, I call that a green light factoring because we just need to set up 2 parentheses and an x and an x. And then your job, go find me 2 numbers that multiply to be negative 35. So your choices are 1 times 35 and 5 times 7. Find the one that you can make multiply to be negative 35, so 1 positive, 1 negative, but add up to be negative 2. Well, I can do that if I have a negative 7 and a positive 5. My 2 answers then, 7 and negative 5. Those will become important later because they'll represent the x-coordinate of a hole, or it'll represent a vertical asymptote. If you look at x squared minus 8x, on this one, they have an x in common. So I'm going to factor out that x, which leaves a x minus 8. Now when I set this equal to 0, I'm going to set that equal to 0 and get 0. I'm going to set that equal to 0 and get 8. So there's those 2 answers. I'm not going to do this 3x squared one. I want to review with you real fast what happens if there's a value out front. You guys called this last year frowny face factoring. Here goes those steps. 2 times negative 3 is negative 6. 2 times that is negative 6. I need you to find 2 numbers that multiply to be negative 6. So your choices are 6 and 1 or 2 and 3. I don't know why that keeps showing up. 2 and 3. Find the ones that you can make add up to be 5. Well, I'm going to have to use a positive 6 and a negative 1. Because when I multiply them, I get negative 6. And when I add them, I get positive 5. Now, I'm going to rewrite this as 2x squared plus 6x minus 1x minus 3 equal 0. I'm going to group the 2x squared plus 6 together and factor out a 2x, which leaves a x plus 3. I'm going to factor out a negative something. The reason I picked the negative is because of that sign right there. They have nothing in common, so I'm going to take out a 1. which leaves a x plus 3. Notice that my sign changed. -1 times 3 is -3. If you've done a good job, these parentheses are the same now. So I'm going to have x plus 3 times 2x minus 1. That's frowny face factoring. Once I set these equal to 0, I'm going to get -3 and positive 1/2. Now, if you would, take a peek at that note card. I'm not going to spend a lot of time here because I'm going to say some things over and over on your video. So, to tell if there's any vertical asymptotes, guys, we're just going to set that denominator equal to 0. I can tell if there's a horizontal asymptote for 3 different reasons. If the power in the denominator is bigger than the power in the numerator, then I'm going to have a horizontal asymptote at y equals 0. If I have the same power in the numerator and the denominator, I'm just going to look at the coefficients. So pretend for just a second I had 5x squared plus 6x, and I had 2x squared minus 8. The x squareds are the same power, so I'm going to have a horizontal asymptote at 5/2. And the last case is when the numerator is the bigger one, but only by 1. Then that's when an oblique shows up. I will show you that when we get to the back page. So, if you would, pop over to your number 1. Hang with me on these, guys, because this gets tricky. So here goes our number 1. To figure out your vertical asymptote, we're going to set the denominator equal to 0. So I'm going to take x plus 1 and set that equal to 0 and get x equal -1. That is going to be my vertical asymptote. So guys, what you might do on your note sheet is put this little note to it. Set the denominator equal to 0. Now the horizontal asymptote. Notice that the highest power in the numerator is a 1. The highest power in the denominator is also a 1. Now look at the coefficients. 1 over 1 is 1. So I have a horizontal asymptote at y equal 1. If there would have been a 2 here, then it would be 1/2. But there is no 2 there, so. If there's a horizontal asymptote, guys, there cannot be an oblique. The other reason, look at your note card. For there to be an oblique asymptote, the power in the numerator's got to be 1 greater. And since they're a tie, it can't be 1 greater. Now the x-intercept, keep this part simple. To get your x-intercept, you're just going to set your numerator equal to 0. So I'm going to set x plus 2 equal to 0 and get -2. So when you list this, y is 0, x is -2. List those as an ordered pair. Now the y-intercept says let x be 0. So guys, you might on your sheet again write these little notes down. If you got to pause the video and write them down, that's fine. But guys, if you let x be 0, check out what happens. This x goes away. This x goes away. I'm left with 2 divided by 1. So when x is 0, my y-intercept is 2. Now, I'm going to get rid of this real fast. The domain. Look back up to your very first line. That tells you the x values you are not allowed to use. You are not allowed to use -1. So my domain, -infinity to -1, along with -1 to infinity. Now, we're going to graph this thing now. What we need to do is decide what scale we can count by. So I'm going to look at my numbers. I've got a -1, a 1, a -2, a 2. I think I can get by with counting by 1s in this problem. So I'm going to count from -5 to 5, and from -5 to 5 on the x-axis. I'm going to come in now and draw my asymptotes. I have 1 at x equal -1. So I have an asymptote right there. I'm going to label that in just a heartbeat. I also have one at y equal 1. So I also have an asymptote right there. So let me label those for you real fast. I'm going to have x equal -1. And I've got y equal 1. Now guys, the graph is going to approach, but normally not cross, your asymptote. There is an example coming up that does. Now plot your other points. I got an x-intercept at -2, 0, so put that on there and label it as -2, 0. I also have a y-intercept at 0, 2. So 0, 2. Now guys, this is all I need to graph. Whenever you graph something, think left to right. So I'm going to be in this quadrant right here. Going left to right, I got to be close to this asymptote, go through this point, and get close to that asymptote. So guys, I'm going to have something like this. I missed my dot, but now on the other one, same thing. Left to right, I'm going to be close to this, go through that dot, and then come get close to that. Bam! I just got that first one done. That's going to be our steps on a lot of these. On number 3, I'm going to throw you for a little loop, but I'm going to quickly go through number 2 because the steps are the same. The more you hear it, the better off you're going to be. So here goes my number 2. To get my vertical asymptote, we're going to set the denominator equal to 0. So we're going to set x plus 3 equal to 0. We're going to get x equal -3. So my vertical asymptote, x equal -3. This one also has a horizontal asymptote. The highest power with that numerator is 2x to the first. The highest power in the denominator is a x to the first. Put a 1 right there. There is your horizontal asymptote. So I have a horizontal asymptote at y equal -2. Now, if there's a horizontal asymptote, there cannot be an oblique one. If this was a squared up here, then there would be an oblique one. Like I said, that's coming up on the back side. To get your x-intercept, set your numerator equal to 0. So I'm going to take -2x minus 5 and set that equal to 0. I'm going to add 5 and divide by -2 and get -2.5. So I have an x-intercept at -2.5, 0. To get your y-intercept, let x be 0. And then that's going to totally wipe out all these x's up here. So they're gone. What are you left with? You're left with -5 over 3. So my y-intercept is -5/3. And that's an ugly 3. Your domain, you can use everything but -3. So my domain, -infinity to -3, along with -3 to infinity. We have everything that we need. When I look at my numbers again, guys, I've got a -3, a -2, 2.5. I think I can get by with 1s again. -5 to 5, -10, -5 to 5. If you're ever in doubt, count big. Count by 2s, count by 3s. Now, let me draw in my asymptotes. I have 1 at x equal -3, so right there. I have 1 at y equal -2. Let me label those now. So x equal -3, y equal -2. come and plug your points in and see if that's enough. So I've got -2.5, 0. So I've got an x-intercept right there. So check my dot out. Now let me label that -2.50. And I've got a y-intercept at 0, -1 2/3. 0, -5/3. So guys, I know enough in this area here. I know I'm going to be close to this asymptote. I'm going to have to go through my dots and then get close to those. So there's the first piece of it. But now, there's probably something happening somewhere over here. I just don't know what's happening yet. So here's our steps now. I need to pick an x value to the left of -3. So I'm going to pick -4. We need to plug -4 back into the original equation and see where that point is. So I'm going to go -2 times -4 is 8. 8 minus 5 is 3. -4 plus 3 is -1. So I'm going to get a point at -4, -3. That's really important. -4, -3 tells me I have a dot right there to draw my rest of my graph in. Close to here, through that point, get close to there. And there's the label for -4, -3. I won't graph all of these guys just because of the length of the video, but there's the two easiest ones so far. Make sure that you understand these things right here, because we're going to use them over and over and over. Now, jump over to number 3. Number 3 changes the game just a little bit. Notice that there's squares in there. Pay really good attention on this, because there's a lot here. What I need to do with this is I need to factor it. I need to factor x squared minus 9. Well, that's a difference of squares. So I'm going to factor that into x plus 3 and x minus 3. The bottom of x squared plus 5x plus 6, I'm going to factor that into x and an x. Two numbers that multiply to be 6 that we can make add up to be 5. Looks like +3 and +2. Now this is huge. Remember earlier I showed you one of those graphs that have a hole in it? This is one of those graphs. Watch what happens. Notice that I can cancel these out. Take x plus 3 real fast, set it equal to 0, and you're going to get -3. I know that I'm going to have a hole in my graph when x is -3. It's the piece that I canceled out. Now, this is huge. Rewrite what's left now. I'm left with the x minus 3 over x plus 2. To figure up the y value, plug -3 into what's left. So -3 minus 3 is -6. -3 plus 2 is -1. The y value of my hole is 6. So let me kind of state what I did again there, guys. What we did first is we factored. And then if something's exactly the same, that's when a hole appears. So cancel those out and rewrite what you have. And then set this equal to 0. That's the x-coordinate. Plug in this value into there to get the y-coordinate. Now, rest of the time we're going to focus on what we have left. To answer the rest of the questions, we're just going to use this right here. There's a +2 in the denominator. So I'm also going to have a vertical asymptote at x equal -2. To get my horizontal asymptote, I've got an x to the first here and x to the first here. 1 over 1 is 1. So I'm going to have a horizontal asymptote at y equal 1. Since there's a horizontal, there is no oblique. To get the x-intercept, it says set your numerator equal to 0, but only look at this piece right here. Set that numerator equal to 0, and you're going to get 3. So my x-intercept is going to occur at 3. And we want that listed as an ordered pair. Your y-intercept, let x be 0. Come back over here. Look at your x's. Throw them away. I'm left with negative 3 divided by 2, which is negative 1.5. Be careful on the domain. On my domain, you are not allowed to use a negative 2 or a negative 3. There's a hole here. There's an asymptote there. So my domain is going to be negative infinity to negative 3, along with negative 3 to negative 2, along with negative 2 to infinity. So that's how we handle that. Now, I'm definitely going to graph this one because I need to show you how the hole goes in there. On some of the rest of them, guys, we're not going to graph them. So, I need to graph the vertical asymptote. First, I need to count by, or decide what I'm counting by. As soon as this 6 shows up, I probably better count by 2's. So in this case, I'm going to go from negative 10 to 10, and I'm going to go from negative 10 to 10. Now, I got a vertical asymptote at x equal negative 2, so since these are counting by 2's, it's going to be right there. I will label that in a second. It's a little crooked. I'm also going to have one at y equal 1, which will be right about through there. So let me come back. Remember, x equal negative 2 and y equal 1. Now let's plug in our other things. I have a hole at negative 3, so negative 2, negative 2, negative 3, 6, 2, 4, 6. I have a hole in my graph right there. So that's how you represent the hole, an open dot. I also have an x-intercept at 3, 2, 3. So I've got an x-intercept right there. Now, believe it or not, that is enough to graph this whole thing. Oh, and I also had a y-intercept at negative 1.5. So about right there. Okay, let's work left to right again. Working from the left, I've got to be close to this asymptote. I've got to come up, go through this hole, and continue on. So there's what that piece looks like. On this one, I'm going to be close to the asymptote, go through the dots, and continue on. So there's what we have real fast. Guys, what I'm going to do is I'm going to go ahead and go through number 4. We're not going to graph it, but I want to show you the math portion of it again. Because the more you see the math, the better off. So number 4, what we need to do is graph it first. So the numerator does not graph, or does not factor, so let's leave it as x minus 3. But look at the bottom. I can take out an x, which leaves x minus 3. As soon as this happens, as soon as you can cancel something out, leaving you 1 over x, I know there's a hole in my graph. There's a hole in my graph when x equals 3, because I set x minus 3 equal to 0. To get the exact location of the hole, plug that 3 right there and get 1/3. I'm still going to have an asymptote because focus on what's left now. If I set that equal to 0, I'm going to get 0. So I have an asymptote at x equal 0. Notice that the power in the denominator is bigger than the power in the numerator. So I do have a horizontal asymptote at y equal 0. That means there is no oblique asymptote. We'll do one of those coming up pretty dang quick. The x-intercept says, set your numerator equal to 0. Well, we can't turn 1 into a 0, so there's no x-intercepts. The y-intercept says let x be 0. Well, if I plug a 0 here, I get 1 over 0, which does not exist, so there's no y-intercept. When you do your domain, you are not allowed to use a 0, right there, or a 3. So I'm going to have negative infinity to 0, along with 0 to 3, along with 3 to infinity. And like I said, I won't take time to graph it, guys. We'd have to draw in our asymptotes and then label the points and then decide how it goes. I kind of want to speed the video up just a little bit. So if you would, let's jump over to number 6. This is our first one that has an oblique asymptote in there. It's going to blow your mind for a second, but hang with it, and then it won't be too shabby. So once again, there's something to be factored, so let's factor this. I'm going to go parenthesis, x and an x. Two numbers that multiply to be positive 3, that add up to be negative 2. Well, check out what I got. To make these add up to be negative 2, I would need a negative 3 and a positive 1. But if I multiply that, I get 3. So that's not good news for us. So what does that mean for you? This thing does not factor. It doesn't factor. So I'm just going to come straight down to here. The vertical asymptote, set your denominator equal to 0. If you do that, I'm going to get a vertical asymptote at x equal 1. Your horizontal asymptote, here's going to be the new part for you. There's not going to be 1 because the power in the numerator is 1 greater than the power in the denominator. Now, see if this sounds familiar. I need to take x squared minus 2x plus 3, and I need to divide it by x minus 1. We did this back in chapter 3. See if this looks familiar. I am going to put a 1 right here and an upside down division sign. I'm going to put the coefficients of a 1, a negative 2, and a 3. Synthetic division. Drop that 1, get 1 times 1 is 1, add it up and get negative 1. 1 times negative 1 is negative 1, add them up and get 2. Now, ignore that right there. The remainder does not matter today. So the equation for my oblique asymptote is going to be y equal. Come over here now for your coefficients. 1x minus 1. 1x minus 1. So synthetic division, and then write it. I'm going to get rid of that so it's not in my way. To get your x-intercept, I'm going to set this equal to 0, and I'm going to tell you now there's none. But to get the y-intercept, let x be 0. If you let x be 0, these x's are gone. I'm left with 3 over negative 1, which is just negative 3. Your domain, you can use everything but 1. So negative infinity to 1, 1 to infinity. Now, to graph this, I notice I have a 1, I have a 0, negative 3. That's getting close. So I'm going to go ahead and count by 2's. So I'm going to go negative 10 to 10, negative 10 to 10. Now guys, whenever oblique asymptote shows up, try to count by the same scale. That way a slope of 1 just means up 1 unit, over 1 unit. If you have different scales, then you're going to have to count odd. So let me start drawing in some things. I have a vertical asymptote at x equal 1, so right there. I'm going to label that in a second. I have an oblique asymptote starting at -1, so that'd be about right there. Because remember, we're counting by 2's. And my slope is 1, so I need to go up a unit, over a unit. And then, let me see if I can draw that with this thing. So my oblique asymptote is going to look something like that. Really, it needs to be up just a little bit, but we'll get the hint. Now come back, and we got to decide how this thing looks. So plot some points that you know. I've got 0, -3. So 0, -2, -3. I'm going to label that out here, since I don't have much room there. Even though there's just one dot there, guys, I have enough to graph this. Start from the left, be close to the asymptote, come up, go through that point, come back down. So there's that piece of it. I got to decide what happens up here, though. So I need a dot. So here's what I need. Since I don't have one in here, I got to go get one. I got to go get one. So I got an asymptote right here at 1. I'm going to pick 2. I'm going to let x be 2, and I'm going to run 2 through this equation here. So I'm going to go 2 squared is 4, minus 4 is 0, plus 3, so I'm going to have 3 over 2 minus 1 is 1. So I'm going to go through the point 2, 3. Over 2, up 3, right there is my point 2, 3. And I have everything I need. Close to this asymptote, through the dot, get close to that asymptote. So there we go. Notice though, guys, my branches each have a point on there, and my asymptotes are labeled. I'm going to do one more with you, and I'm going to quit because I notice my video is already 32 minutes long. Let me show you what number 7 is going to look like. So once again, this one has a little bit of stuff to it again. I need to factor it if I can. So I'm going to have x plus 2 times x plus 5 over x plus 1. Notice this. You can't cancel anything out. So the one thing that I know, there is no hole in this graph. There's no hole in this graph. My vertical asymptote, set that denominator equal to 0 and get x equal -1. There's no horizontal asymptote because the power in the numerator is 1 greater. So here's what I need to do. Set x plus 1 equal to 0 and get -1. List your coefficients, 1, 7, 10. Quickly do synthetic division, so drop that 1. -1 times 1 is -1. Added up is 6. Is -6 is 4. Throw this away. My oblique asymptote, y equal x plus 6. Y equal x plus 6. To get your x-intercepts, set your numerator equal to 0. And if I do that, I'm going to get -2, 0. And I'm going to get -5, 0. To get your y-intercept, let x be 0. And plug it either in here or here. If you plug it to your original, you're going to get 10 divided by 1 is 10. Your domain, we can use everything except for -1. So there's where I am so far. Now, notice in this case, I've got to get 10 to fit. So when I graph this, I might count by 3s, I might count by 4s. I think in this case I'm going to count by 4s. So that's going to be 4, 8, 12, 16, 20, negative 20, 20, and negative 20. I'm going to draw in my vertical asymptote at way over here at x equal negative 1. So since I'm counting by 4s, it's going to be kind of close there. To get this oblique asymptote, I need to start at 6, which would be 4, 5, 6, right there. And I need to do a slope of 1. So up 1 and over 1. So something right in there. Let's draw that in then. Something right in there, I hope. Even though this looks confusing now, oh, the way you label your asymptote, your horizontal, your oblique, y equal x plus 6. You just tell the world what that it was. Now let's plot some points. I got negative 2, 0, which is going to be about right there. I also have one at negative 5, 0. 4, 5 would be right there. I also have 0, 10. 2, 4, 6, 8, 10. 4, 8, 10. Believe it or not, that's enough to graph it. Close to your asymptote, through these points, back down to this guy. Close to this asymptote, through that point, go get close to that guy. Okay. So guys, and I'm not going to do number 8, it's the same thing. But guys, that's the lesson. It's a tough lesson, 36 minutes, so do your best on the worksheet. Come in with any questions that you might have. Good luck to you guys.